In the beginning, there was darkness. Then, a cosmic explosion of light. Galaxies collided, stars were born, and in the midst of this chaos, humanity opened its eyes to the universe. We are tiny, fragile sparks of consciousness, staring out from a pale blue dot, daring to ask, are we alone in this infinite expanse? The question echoes through time, across deserts, mountaintops, and the silent void. Is there life beyond our world, gazing back at us? This relentless curiosity has driven philosophers to ponder, poets to dream, and scientists to reach for the impossible. For millennia, we have built instruments to pierce the darkness, chasing shadows, searching for signs, refusing to accept silence as the final answer. This is not just science, it is a quest for meaning, a search for our place in the grand cosmic story. We built ever more powerful eyes, telescopes that could reach across the void. We scoured the surfaces of Mars and Venus, desperate for a whisper of life, a single sign that we are not alone. We searched every corner of our solar system, following every clue, every shadow, every possibility. But the real mystery, the true hope, was always out there, hidden among the countless stars blazing in the night. Then a revolution, the discovery of exoplanets, worlds orbiting distant suns. Suddenly the universe was alive with possibility, each star a beacon, each planet a potential home. The galaxy became a sea of unknown worlds, each one waiting to be discovered, each one a question mark in the dark. But these first glimpses were indirect, shadows and hints, not the worlds themselves. We saw only the faintest clues, never the full glory, never the true face of another Earth. We measured, calculated and dreamed, always reaching, always hoping for more. But the surface, the atmosphere, the secrets of these distant worlds remained hidden, just out of reach. The dream of seeing another Earth, alive, vibrant and real, remained a distant hope, a vision shimmering on the horizon. Until now. Enter the James Webb Space Telescope. A new era begins. A marvel of human ambition, built to transform dreams into reality, to reveal the unseen and answer the oldest question of all. With its golden mirror and revolutionary vision, it gathers the faintest whispers of light from across the cosmos. JWST was built to confront the greatest mysteries, to seek our origins and our place in the universe. And now, on this day, July 22nd, 2025, the impossible has become real. We have our first glimpse, a breathtaking image, a revelation that forever changes our understanding of life beyond Earth. In the vast cosmic ocean, stars are like distant islands, and among these stellar isles, our closest neighbor is Proxima Centauri. This faint red dwarf star resides just over 4 light-years away, a seemingly short distance in the grand scale of the universe. It's a celestial body that has captured the imagination of scientists and space enthusiasts alike. Orbiting this diminutive star is Proxima b, a planet that holds the potential for harboring life as we know it. This exoplanet was discovered in 2016, a monumental achievement in our ongoing quest to find other worlds. Proxima b resides within the habitable zone of its star, often referred to as the Goldilocks zone. This is the region where temperatures could allow for liquid water to exist on the planet's surface, a crucial ingredient for life as we understand it. For years, Proxima b was more of a theoretical construct than a tangible world. Its presence was inferred from the subtle gravitational tug it exerted on its parent star. It existed as a statistical ghost, a tantalizing possibility hidden within the data. We knew its approximate size and the parameters of its orbit around Proxima Centauri, but its true nature, its very face, remained elusive. The extreme proximity of Proxima b to its star made direct observation incredibly challenging, like trying to spot a firefly dancing in front of a powerful searchlight. The star's intense glare overwhelmed any faint light emanating from the planet. All we had to work with were computer models, simulations, and educated speculation, piecing together a picture of this distant world based on indirect evidence. But the James Webb Space Telescope, with its revolutionary capabilities, was specifically designed to overcome this challenge and peer into the darkness surrounding distant stars. Unlike traditional visible light telescopes, which are blinded by the glare of stars, JWST is equipped to see in infrared, the realm of heat radiation. This allows it to detect objects that are too faint or too cool to be seen in visible light. Proxima b, though dim in visible light, radiates a faint but detectable thermal glow, a heat signature that betrays its presence. JWST was meticulously engineered to detect this faint thermal radiation, employing advanced techniques to separate the planet's subtle heat signature from the overwhelming glare of its host star. This is achieved using a coronagraph, which blocks out the star's light, allowing the much fainter light from the planet to be seen. This ambitious mission pushed the boundaries of space-based technology to its absolute limits, demanding unprecedented precision and sensitivity. The ultimate goal was to transform Proxima b from a mere deduction, a statistical inference, into a tangible world that we could directly observe and study. And now, thanks to the groundbreaking capabilities of JWST, for the first time in history, we have obtained a direct image of Proxima b. Proxima b is no longer just a ghost in the data, a figment of our calculations. It's a real place, a tangible world with its own unique characteristics and potential. This monumental achievement has profound implications for the search for life beyond Earth, making the prospect of finding extraterrestrial life all the more compelling and within reach. The search for life just got a lot more interesting. Capturing Proxima b's image was a feat of engineering. JWST used a coronagraph, an artificial eclipse, to block the star's light. Its sensitive infrared cameras, NeoCam and MIRI, hunted for the planet's faint heat. For weeks, JWST collected photons, stacking hundreds of images to reveal a signal. Advanced stabilization kept the telescope perfectly still. Powerful computers processed the data, subtracting scattered starlight. Slowly, Proxima b's unique heat signature emerged. This is not an artist's impression. It's a genuine image, built from photons that traveled over 4 light-years. We've crossed a threshold, from knowing exoplanets exist to seeing them as real worlds. The image, captured by our most advanced telescopes, represents a monumental achievement in astronomy. It's a testament to human ingenuity and our relentless pursuit of knowledge about the cosmos. Just a few pixels, a faint glimmer of light painstakingly gathered from an unfathomable distance, yet it speaks volumes. It's a portrait, albeit a rudimentary one, of a world beyond our own. Reveals a world of rock and stone, a terrestrial planet much like our own Earth, but orbiting a different star, light-years away. Proxima b is confirmed as a rocky Earth-sized planet, residing in the habitable zone of its star, Proxima Centauri, the closest star to our Sun. This makes it a prime candidate in the search for extraterrestrial life. Its heat signature, meticulously mapped by sophisticated instruments, shows a dramatic temperature difference. One side is much warmer, perpetually bathed in the star's radiation, while the other is much colder, shrouded in eternal darkness. This stark contrast presents unique challenges and opportunities for potential life. This is direct evidence that Proxima b is tidally locked, a phenomenon where a planet's rotation period matches its orbital period. One side always faces its star, basking in constant daylight, while the other is in perpetual night, forever turned away from the warmth and light. The day side bakes in endless noon, a scorching landscape under the constant glare of its star. The night side freezes in darkness, a frigid expanse where temperatures plummet to unimaginable lows. Yet there's a hint of a thin atmosphere, a delicate envelope of gases clinging to the planet's surface. Heat bleeds from day to night, carried by winds and atmospheric currents, softening the temperature divide and creating pockets of potentially habitable conditions. This veil of gas could be crucial for habitability, shielding the surface from harmful radiation and distributing heat more evenly. The thermal map shows hotspots, possible signs of volcanic activity, hinting at a dynamic and geologically active world. Volcanoes could replenish the atmosphere, releasing gases from the planet's interior and fighting the constant erosion caused by the star's radiation. Proxima b is geologically active, dynamic, and potentially stable over long timescales, offering a glimpse into the possible futures of terrestrial planets. But there's no sign of artificial lights, no evidence of advanced life, at least not in a form that produces detectable illumination. The search continues. Proxima b is a world of extremes, scorching dayside, frozen nightside, but between them lies the Terminator Zone, a perpetual twilight band. Here, temperatures could be moderate, just right for liquid water. This narrow strip may be the planet's oasis, a ribbon of life circling the globe. Life, if it exists, might thrive in this eternal dawn. Powerful winds would sweep from hot to cold, shaping global weather. The thin atmosphere, suggested by JWST, could help transport heat and protect against radiation. The key question, what is this atmosphere made of? Water vapor, carbon dioxide, methane? The Terminator Zone is where we'll search for signs of life. Proxima b faces a relentless threat, its volatile red dwarf star. Proxima Centauri unleashes powerful solar flares, blasting the planet with radiation. These flares could strip away the atmosphere, boiling water into space. The planet's survival depends on a delicate balance. Can it hold on to its atmosphere? A strong magnetic field could shield it, but we don't know if one exists. Volcanic activity might replenish lost gases, creating a dynamic equilibrium. Proxima b is not a tranquil paradise. It's a world on the edge. Its habitability hangs between creation and destruction. Here, life would have to fight for every moment. The first direct image of Proxima b is a turning point in our exploration of the cosmos. For generations, exoplanets were shadows. Now they are places. JWST has made us planetary explorers, mapping worlds light years away. This breakthrough will transform how we study exoplanets, allowing us to search for biosignatures, chemical hints of life. The search for life is now testable science, not just speculation. Proxima b's image inspires a new generation of explorers and dreamers. It brings the dream of interstellar travel a little closer. We stand at the dawn of a new age of discovery. The ancient question, are we alone, remains, but now we have the tools to find out. The journey has just begun, and the universe is waiting.